Let's discuss some questions of this chapter. First question: if the HCF of two positive integers a and b is 1, then their LCM is dash. So HCF of two positive integers a and b is 1. So given HCF is equal to 1, we know HCF of AB multiplied by LCM of AB A into B. So LCM of AB will be equal to A into B divided by HCF of AB. Here given as HCF is equal to 1. So A into B divided by 1, that is equal to A into B. So LCM of AB, where HCF is 1, is A into B. So the answer is D. Next question. The number 3 plus root 2 is dash, a rational number, an irrational number, an integer, a natural number. Here given 3 plus root 2 is rational. So the sum of rational and an irrational number is always an irrational number. Therefore, the answer is B, an irrational number. Third question. Assertion: for any two natural numbers a and b, the HCF of a and b is a factor of the LCM of a and b. Reason B. HCF of any two natural numbers divides both the numbers. Here, first option is given as both A and B are true and B is the correct explanation of A. Both A and B are true but B is not the correct explanation of A. C, A is true but B is false. D, A is false but B is true. HCF of any two natural numbers divides both the numbers. Yet, yes, it is true, that is HCF is the highest common factor, that is HCF divides A and HCF is also divides B. So that implies HCF divides A and HCF divides B. So the reason B is correct, and using this we can prove the assertion for any two natural numbers A and B. The HCF of A and B is a factor of the LCM of A and B. So here HCF divides A, which implies A can be written as HCF into a factor, let it be X, and HCF divides B implies B can be written as multiplication of HCF and a factor written as Y, where X and Y are integers. We can write A is equal to HCF into X and B is equal to HCF into Y. LCM is the product of the numbers divided by HCF, that is A can be written written as HCF into X multiplied by B can be written as HCF into Y divided by HCF. We can cancel one HCF. So HCF into X into Y is the LCM. That is, from this we can say that HCF divides LCM. HCF divides LCM means HCF is a factor of LCM. Hence the proof. So we can conclude that the two statements are true. Both A and B are true, and B is the correct explanation of A. Next question, prove that root 3 is an irrational number. Fifth question, the factor tree of a number x is shown below. X and it divided by 2 and gets y. Then y divided by 2 we get 210, and 210 divided by a we get 70, and then 2 into 35 is 70, and 5 into b is 35. So find the values of x, y, a and b. Hence write the product of the prime factors of the number x so obtained. Look at this portion. So we can see that 35 is get by 5 into b. So 5 must b must be 7, because 5 into 7 is 35. So we get b is equal to 7. Next we can see that in this part 210 is get by a into 70, that is 3 into 70 is 210. Therefore, A is equal to 3. Next, we got Y by multiplying 2 into 210. So, 2 into 210 is equal to Y, which implies Y is equal to 420. Next is y is 420. So we get x is equal to 2 into 420. That implies x equal to 840. So we get x equal to 840. Hence, write the product of the prime factors of the number x so obtained. So, x is 840, which is equal to a is 3 and b is 7. X is 840. So, we can write 840 is equal to the power 3 multiplied by 3 multiplied by 5 and multiplied by 7. Product of the prime factors, which is the prime factors are 2 into 3 into 5 into 7. So the product of prime factors 2 into 3 into 5 into 7, that is equal to 2 into 3 6, 5 into 7 35, that is equal to 210. Next question, The HCF of the smallest prime number and the smallest 3-digit number is 2 raised to m into 5 raised to n. The respective values of m and n are option 1, option A 0 0, option B 1 0, option C 0 1, option D 1 1. So smallest prime number is 2 and smallest 3-digit number is 100. 100 can be written 2 into 50. 2 into 50 can be written as 5 into 10. 10 can be written as 2 into 5. So 2 the power 2, 5 the power 2. So 100 can be written as 2 raised to 2 into 5 raised to 2. HCF of the two numbers 2 and 100 is the common factor in the two numbers are 2 and its smallest power is 2 raised to 1. So 2 raised to 1 and 5 is not common. So we got 5 raised to 0. 5 raised to 0 is 1. So we can write 2 the power 1 and 5 the power 0. So value of m and n is 2 raised to m, 5 raised to n is equal to 2 raised to 1 and 5 raised to 0. So m is equal to 1 and n is equal to 0. So the answer is B 1 0. Sixth question. Which of the following statements is true? For HCF and LCM of two distinct natural numbers A and B. First one is HCF is always greater than LCM. Second, HCF is a factor of LCM. Third, LCM is a factor of HCF. So first option is given. 1 is only true. B 1 and 3 is true. And C 1 and 2. D 2 only. So let's take these three statements. The first one is given HCF is always greater than LCM. HCF is the common factor which is highest common factors in both two numbers, but LCM is the multiplication of the factors of highest powers. So HCF is common in both two numbers. We can say that HCF is always less than LCM. HCF is the smallest one. For example, let's take two numbers 6 and 4. 6 can be written as 2 into 3 and 4 can be written as 2 the power 2. HCF of two numbers 4 and 6 is the number which is common in two numbers factor which is common in two numbers is 2 the power 1 and LCM is equal to all the factors, that is 6 the power 3, 3 the power 1 multiplied by in 4 to the power 2. So which is 2 and LCM is 4 into 3, that is 12. So HCF is always less than LCM. Here we have given that HCF is always greater than LCM. So this statement is false. Second statement, HCF is a factor of LCM. That we have already proved in previous question. let since HCF is a common factor in both A and B, we can say that HCF divides A and HCF divides B. So HCF divides A implies A can be written as the product of HCF and an integer, let it as x. And HCF divides B implies B can be written as the product of HCF and an integer, let it be y. Then we know LCM into LCM, HCF. We know HCF into LCM of two numbers is equal to A into B, the product of two numbers. From this, we can say that LCM of AB is equal to A into B divided by HCF. A can be written as HCF into a number x, and B can be written as HCF into y, all divided by HCF. HCF can be cancelled, so we get HCF into x into y. So from this we can say that HCF is a factor of LCM. So the statement is true. HCF is a factor of LCM. In third statement, given as LCM is a factor of HCF. Since LCM is greater than HCF, a greater number which cannot be a factor of small number. The LCM is large number and HCF is small number. So LCM cannot be a factor of a large number, cannot be a factor of a small number. Therefore, this statement is false. So D 2, the statement 2 only is the true statement. So 2 is the only statement which is true.